Okay, so in this picture, it's important to note first of all that it's on an interval, so there are endpoints on this function. It's not continuing on infinitely in any direction. These are endpoints of the function, which sometimes will be the case and sometimes will not. And the rest of it is pretty self-explanatory. Okay, so these definitions make sense for what they're talking about. So the absolute minimum is the very smallest point on the function, and when we're talking about small, we're talking about really the y values. Okay, for how high and low it is, we're talking about the output values. Okay. Okay. So how far up or down it is. So this is the very lowest point, so that's the absolute minimum. There's no smaller value of the function anywhere else. And then up here, the orange is the absolute maximum. That's the very highest point, again, in terms of the y values, and there's no greater value of f anywhere else. And then there's also things called local minimums and maximums, and that is a minimum or maximum for like an area. So in this case, the green is a local maximum because in this portion of the graph, that is the highest value of the function. There's no greater value of f in the nearby area. And then both of these, there's two in this function, there's two local minimums. So the local minimums, there's no smaller value of the function, again, anywhere nearby. Local minimum and maximum are sometimes also called relative minimum and maximum. And altogether, minima, I should say, minima is the plural for minimum, and maxima is the plural for maximum. But together they're called extrema. So minima and maxima, all collectively are called extrema. And the extreme value theorem says that if a function is continuous, remember continuous just meaning like we could draw a line with our pencil and not pick it up, on a closed interval, like this I said is a closed interval because they have endpoints, okay? You will be seeing the bracket notation, which we've done a little bit, but I think maybe we should review that. If it has a bracket, that means that it includes the point. So that means, this would mean everything between, I shouldn't use x and y, everything between A and B, including A and B. So like a closed interval. You've seen that before. And if they are parentheses, that's just everything between. So that does not include the A and the B. And if that is the case, the extreme value theorem does not apply. It has to be a closed interval. And we can have a mixed interval too, where like one is a bracket and one is a parenthesis. That would mean it includes this and it doesn't include this. So this would include A, and it would not include B. And we could also have the opposite of that. Only write down what you need to if it makes sense to you, if you think you do need to write it down. So this would not include A. but it would include.
So the partial ones, do those not?
Those do not apply either, no.
Okay.
So the only time the extreme value theorem will work is if it's a closed interval. Otherwise, there might not be a maximum or a minimum. If you think about the quadratic function, if I don't have an interval for this, what's the maximum? It goes on to infinity in both directions. There's no maximum, it never ends. But if I have a closed interval, then I can say where the highest point on that interval would be. Okay? So, like I said, local extrema are also called relative extrema, so you could also say it's a relative minimum or relative maximum instead of local. And an absolute extremum is also a local extremum. So all of the extrema are local. Local extreme values. If a function has a local maximum value or a local minimum value at an interior point C of its domain, and if the derivative f prime exists at C, then the derivative at C will be 0. So here's what that means. Ready? Oops. Sorry, Lauren. Okay, so what they're saying is if we have a local max or a local min and it's within the function, it's not at the endpoints, then the derivative will be 0. The derivative, remember, is the slope of the tangent line. It's been a while since we've talked about this, but we've been doing derivatives, but I know we tend to forget what it means. So remember, the derivative is the slope of the tangent line. So anytime you have a maximum or a minimum value and you draw a tangent line at that point, it's going to have a slope of 0. Right? So in order to find the maxima and minima, we're going to have to find the derivative and then figure out where the slope is 0. A critical point is any point in the interior at which the derivative is 0 or the derivative does not exist. So these are called critical points. as well as local max, local min. They're also called critical points because they tell us a lot about the function. And the extreme values will only occur at the critical points and at the end points. So if we can find where the derivative equals 0 or where the derivative does not exist, then we can figure out if those are local maxima or minima, and we could also look at the end points of the function if it's on a closed interval. Okay, so you might not have any homework today because you might just be doing it. But so to find the extrema, we're first going to find the derivative of the function. Then we will set the derivative equal to 0. And then you will solve for x to find the x coordinates of the critical points. And remember, the y coordinate is really what determines if it's a minimum or a maximum. So we have to also plug it back into the original function to find the y coordinates of the critical points. And then we'll need to figure out what the y coordinates are of the end points to compare those as well. Sorry. do an example together and then you won't have any homework today. We'll do homework tomorrow. Okay, find the absolute maximum and minimum values of f of x equals x to the 2/3 on the interval -2 to 3. Okay, so one of the first things, besides finding the derivative and do all of the steps that we just talked about, another thing you might want to do first is just look at the graph of the function, because by looking at the graph of the function, you're going to be able to see what the maximum and minimum is going to be. So if you, we don't have to do that today, but do start bringing your graphing calculators if you haven't. Because we're going to just put it into the to the calculator, because a lot of these it's a lot easier to see where the maximum and minimum are going to be if you just can see what the shape of the graph looks like. But without doing that, we can do it by finding the derivative. So we'll find the derivative of x to the 2/3, which would be what?
-1.
Right. 2/3 x to the -1/3, and then we figure out where that will equal 0. So you might want to write that as like 2/3x to the 1/3. So where is that going to be 0? If you have a fraction, when would the fraction be 0?
Denominator 0. The numerator 0.
When the numerator is 0, right? And it can't ever be 0, so that's never going to be 0. But remember, a critical point is also where it is undefined. So where would it be undefined? If you have a fraction, when is the fraction undefined? Okay, like 0/5 is 0, right? What's 5/0? So when is a fraction undefined?
Denominators.
When the denominator is 0, right? So in this fraction, when would the denominator be 0? When x is 0. Right? Because there's just one term in the denominator with an x in it, so if the x is 0, then the denominator will be 0. So there's a critical point where x is 0. I need to figure out the y coordinate of that point is. So if I put that back into the original function, I'd have 0 to the 2/3, which would be 0. And then we'll have to figure out what the end point values are for y. So we know that the end point coordinates are -2 and 3. And so in order to figure out their y values, we'll have to plug those into the function, so f of negative 2 will be negative 2 to the 2/3, which would be negative 2 squared would be 4, 4 through to 4, 4 to the 1/3.
How come the 3 is an x too, even though it's written like negative 2 comma 3?
Because that is the interval notation. That's like saying x is between negative 2 and 3. That's
Okay.
not an ordered pair of coordinates.
Okay.
And then we'd have to put in the 3. We need to wrap this up because it's selfishly but 3 to the 2/3, 3 squared would be 9, so it'd be the cubed root of 9. We'll finish that tomorrow too.